Teďka si co to je, takový nástroj.
Protože jako kolika firmy dělá krabice jako migrace a druhá jsou RP,
There's some spots in the first row. It's the perfect place to be. I see a lot of them. Like the whole first row is empty, so don't be shy. It's the best place in the house. There won't be any better. You won't be able to find any better than these. Perfect. The biggest fans. You see that? Better more? A bit? A little bit? Now? Don't mess it up. Does it work? Yeah, better? I don't know. Maybe. Alright, guys. Welcome. It's great to have you here. Thanks for coming. Please take your seat. First row still empty. Anyway, so welcome again. I'm happy to have you here. This is already our 15th meetup, Backendisti.cz. It's a meetup that we organize for people passionate about backend technologies, cloud technologies, DevOps technologies, anything related to that. This evening we'll have two amazing talks. One of them will be about big data serving methods, and the second one would be about use of AI in various stages of development. So hopefully this will be entertaining talks, and you'll be able to learn a lot of new information. I would like to also use this moment to introduce the organizing team. So it's me, I'm Victor. I'm a CTO and partner at GTO Wizard. GTO Wizard is a learning platform helping poker players crash their competition. So we're focusing on the elite players. But some of you might know me also as a previous CTO at Backendisti.cz. So that's me. We also have Peter over there. Peter is working in Datavari, and we've been organizing these events since day one together. Datavari is a tool for consultants and also creating a tool for e-commerce, connecting platforms together. Because he wasn't able to tell me one sentence how to introduce this company, so this is what we ended up with. We also have Lukáš somewhere over there. Lukáš is working on a VC fund in Cargo Ventures, and we have Dan over there working at make.com. One of the unique aspects of this meetup is that for every event we have a different venue. So it's our 15th venue, and for that I'm grateful to SimilarWeb for helping us organize this event, for making sure you have a lot of refreshment over there. And we have also this perfect event space, and also of course one of the speakers that I'll introduce shortly. And because we believe in the power of community, after the talks there will be an opportunity to network, so please don't go home after the talks. There will be a lot of chances to talk with the speakers, ask additional questions or whatever you would like to know off the record. So that's for some, I think, will be the most interesting part. And last but not least, we have Slido for questions. So whenever you go to slido.com, enter the code Backendisti, you'll be able to ask the questions even during the talk. There's also voting, so if you're shy to ask a question, you can at least vote for some others, and the speakers will be happy to answer the questions after the talk. So that's that from my side, and I would like to introduce our key speaker, Joachim from SimilarWeb, and over to you.
So I didn't know there is voting, so I'll do my best. So I'm Yoav. I'm already 8 years in SimilarWeb, leading our main platform, which contains a lot of teams and data, apparently. A very quick introduction to what we are doing, not to sell you our product. Most of you probably need it, but to understand the state of mind and that we are actually, our R&D is kind of a huge data pipeline, so everything we are doing is related to data. Digital marketing intelligence platform, basically, we are monitoring the web, and I will explain in a moment. We are splitting into main 5 solutions. So in our digital research, questions like who is interested in running Drift, okay, more of a market research purposes. Digital marketing probably is most known for you sitting here about SEO, PPC, running campaigns, optimizing keywords and search terms for engines. And sales intelligence, those 3 are under me for prospecting and using our digital data to find potential companies to be our customers in the digital world. So, a bit about our data processing. Sorry about the intense slide, but it was already made, so someone need to use it. We are actually split in the R&D to 4 main groups or orgs. One for collection, basically the guys that are creating this giant internet hole, if you want to look like that. Then, of course, there's a lot of data, a lot of work to do on the data, so it can be then analyzed and create the model. So I always like to use the concept of giant election poll, where we have a very small sample, but we are trying to estimate the entire population. And then this is my job, creating products on our endless data lake. So very quickly, we have many pipelines like that in the company. This is a typical state of where we're using schedulers to run mainly Spark jobs. And then we have tons of databases that we're using currently. We've tried in the past. We had plenty of POCs on everything. We have legacy, we have new, we have good, we have bad. Really, we tried it a lot. We're spending tons of money on AWS, all our stacks on AWS, in order to process the data. So we did very intensive work on analyzing and exploring the data selling methods. And the purpose today is to share it with you. So let's get into details. I'm really trying to do it as practical as possible. If I'm starting to speak Chinese, so if there is any Chinese speaker in the audience, let me know. I will try to rephrase. And Hebrew, no one is speaking Hebrew probably. So key value versus execution engine. So in high level performance, key value is super fast, super efficient, right? We have a key, we're just accessing it super fast, and this gives us the ability to have a sub-second performance and potentially endless scale, right? We can add more compute power, of course, but the idea is very simple. When we are going to execution engine, most of you probably know MySQL or PostgreSQL or any SQL-like engine, even Snowflake or Firewall that we'll talk about, they give you the ability to analyze the data better, but the concurrency and the speed very depend on the resources and the spec of the engine, okay? It's tricky. Updating data, key value, the same. We're accessing the key, we're updating it, easy. There are exceptions, but on high level, that's the idea. And when you are dealing with giant SQL engines, updates are very risky, unstable, pretty hard, sometimes impossible in some technologies that are not really made for scale. Try to handle 70 terabyte database in MySQL and run an update, tell me how it went. And for the complex queries, that's actually where the execution engine wins, because in key value, you need to process data manipulation in the application layer most of the time, okay? DynamoDB, for instance, you can scan the database. It's super costly, super inefficient, very limited. Cost depends, and we're going to talk about it. Let's start with Dynamo. Anyone experienced with DynamoDB? We have 1, okay, 2. So we're gonna have probably around 60 soon. First of all, fully managed, okay? You don't need any background with DevOps or database optimization knowledge. You get all not for free, but you get it all on AWS platform. It's serverless, meaning you don't even need to define any amount of machines or CPU or RAM that you want to use. You get it like a magic. Global tables, okay? And similar way, we are running active-active in 2 regions on the States for of course, being always live for our customers. And that's also a feature that is out of the box in DynamoDB, which is amazing. Handling active-active can be a lot of burden, as our own codes. And reliability, DynamoDB is one of the only products I really experienced that is like really 99 point whatever, always live, always on, always responsive, always 5 millisecond response time, really. Okay, so starting with some riddle. This is a popular website. Most of you probably use it on a daily basis. Exploded starting from December 22 and up until now. Who can guess? Starting with chat, ends with GPT. Okay, so OpenAI.com. Just for the example of our super basic typical graph that you can find even on our free website. And this is something that I want to use to follow my DynamoDB drill down example. Okay, so key is of course unique. What we are doing in similar way when we're using Dynamo key value store, we have some unique identifier. So for example, domain, OpenAI.com, the date of the traffic, the visits, the users, whatever. We are also using data versioning. So imagine like a huge Git for data, because we are sometimes changing and updating the algorithm. So we're also using it inside the key, the suffix, to be able to switch between versions. Okay, not trivial, but works. So that's just a very, very, very naive example of how we will model the data, right, with the version, of course. So this is like an example of how we actually grasping the data. Well, of course, we'll catch multi-gets. We can, if it's a month, so it will be 30 keys. If it's a year, it will be 365, depends on the year, or 66. And then all the manipulation, like I said in the beginning, will be on the application layer, in the application memory. That means, given sorting, aggregation, you want to find anomalies, anything, the database is not really meant for that. Okay, and that's fine. It's even giving you great performance until it's not. And we'll get to the place where it gets tricky. Okay, even if you want to be a bit more complex, that's possible. Dynamo can store objects, so you can actually, you need to pay, I don't remember by heart everything, but still, but remember, when we are doing this, we will need to take the values out in the application memory, a lot of work in the backend, and not only on the database. Okay, that's the main idea, the main difference. Okay. Yeah, so, too far. Okay. How many here work with AWS for some reason? Too shy? Okay, makes sense. So the pricing is complex, right? It's super complex. Yeah. And in DynamoDB, we have a concept that's called read and write capacity. Okay, why? That's the reason you become rich in this world. 2 general tiers, and bear with me. We have the on-demand option, which is supposed to be like simple. You will pay $1.25 per million writes, all right? And then you will pay quarter per read, and basically pay as you go. Okay, that's the on-demand state. But that's actually pretty expensive when you're talking about writing millions or billions or trillions, we have like that, of rows each day, each month, okay? And then you have the provision, I don't know if you can read it, but it's like $0.00065 per unit per hour. That till today I don't even know what it means, but it's cheaper. But you need to define the provision limit. Okay, so it means whoa, it's all the old. You got it all. Cool. I'll stay here. Okay. Oh, no. Okay. So you have a write limit, okay? You need to, let's just stand here. You have a write limit and a read limit. You need to define the limit, and you can only.
You wanted this clicker so much.
Yeah, I cannot think of it. I will sit right next to the clicker. And you need to increase it before you are doing the write. Okay? Why? Just a little context if it's not clear. We are ingesting data, new data, on a daily or a monthly basis. Most of the time, we have some on-demand, but let's put it aside. And then we don't want to pay for, let's say, 1 million units per hour all the time, right? Only when we write. So we have jobs that know when we start writing, we are increasing, and then when we finish, it's increased to 0 or really minimal. And that's the deal. Anyhow, when you're writing 7 billion records, it's expensive, okay? Believe me, it's expensive. You will see a graph in here. Optimizing with S3 import. So we are good friends with Amazon in Israel, especially. They are a lot of money, and we asked for like 3 years to be able to just import a bunch of rows to DynamoDB and potentially to have it in a normal price. So it exists since I think a year and a half ago. And then the process looks like that. Okay, you have the job, and then you can basically just give DynamoDB some CSV or JSON file, and you get a huge batch being loaded automatically to DynamoDB with a normal price of 15 cents per gigabyte, which is still makes sense. And this is an example for a real drop in the price of one of our huge tables. So you see, yeah, that's real numbers, like 15,000 per month. That's how we got with read capacity, write capacity, getting up, going down, increasing. Eventually, it can save tens of thousands of dollars on a monthly basis. Okay, so this is a great tip. But there is a pitfall. It works only for creating new tables. So what we did is we started to creating a mechanism that we can create every month a new monthly table. Okay, we can live with that. A bit annoying, but what we did understood after done is that there is a huge advantage because now we can monitor. Those are real tables in production, and think of it: we are serving data. Most users will use the recent data, like the last 3 months, last year. So eventually, it gives us great visibility for the data that is less in use for customers. Not only that, we can easily drop it, or we can easily change plan. Because AWS pricing team is genius, what happened is that when you are going to a low tier, like you're in S3, you pay less. And that gives us the ability to decide which tables will give us a bit slower performance, but we will pay less, and which will stay super, let's call it, hot or active, and will cost more per gigabyte. So this is the story behind our DynamoDB cost optimization. And as you can see, and as I tell it, it's probably solved, but we still have few issues that Dynamo can't really give us a proper answer for. So first, data storage can still be crazy when we are talking about something like $250 per month per terabyte. Okay, we have in production over petabyte of data being served, not even talking about what we analyze offline, but talking about what we are actually serving to customers. Okay, and complex queries still impossible. Okay, now, complex queries in the backend become irrelevant when we are starting to talk about very huge tables that we want to manipulate with millions of rows. Okay, if you have thousands of rows, that can work. Tens of thousands, okay. Hundreds of thousands, you're starting to hear some graphs, and this is where you really need SQL engine, normal engine, can do those things easily. 4 years ago, we met, even 4.5, exactly when I started my new position in SimilarWeb. We started some talks with a startup called Firewall. Back then, Snowflake was the cool guy in the neighborhood of data analytics. And those guys came to say, hey, Snowflake is super expensive, and we can do it like 10 times faster. So it was sound promising. We had a POC or two, and then I got the risky decision of let's go with them to production because they are the only one who can do it, and they of course did it for almost free. So why not? Since then, really, we did a lot. Firewall just came out with their actually live, like the first general available version. So yeah, this is how risky I am, but it was worth it eventually. Advantages in a nutshell. So super fast columnar database. Those of you who use whatever, Presto, Druid, any other columnar-based Redshift, you know the advantages. Basically, the number of rows is not really a matter for the database until you get to the gazillion numbers, but really, it can eat it all. Compute storage separation. So those of you who are familiar with Redshift or with Snowflake, Snowflake basically came with this initiative. I don't know if it's a patent, but with this whole at first, where you can actually have the same database being analyzed by multiple engines, clusters, okay? There is a huge advantage when we're talking about writing and reading, you get that in a moment. What Firewall initially had, a very huge advantage, is a warm-up mechanism built in. What it does, very important. So basically the high performance is working on the disk that is inside the cluster. SSD disk, fast. When you're analyzing directly from S3, there is high latency. So what basically happens is that when I'm querying for the first time, I'm loading data from S3, and then it's in my, let's call it cache on SSD, and it happens automatically, and I will show you in a moment. By the index, it defines the ranges of the data we get into. Sparse indexing, also a very common term today when talking about big data, when the index is not really indexing the entire data, it's sparse. So it's imaging a lot of chunks, and for each chunk I'm taking only like a certain percentage. So then the index is smaller, is faster, but you have some deviation, but not something that the human eye should identify. So that's the idea. And of course, fully managed. Again, you can load clusters, shut it down, magic. Cool. The loading method in Firewall supporting many files. We are actually using most of the time ORParquet or ORC, very common when dealing with the Spark jobs, those of you who ever did. But this is the idea. The loading itself, of course, is with the API of Firewall. Real example, maybe tiny, probably for some of you, but just for the example, May 2024, United States, Amazon.com, all the keywords that we identified that Amazon.com got traffic from. So we're talking about a single month, 10 million keywords, okay? And now basically what I want to do is to say, okay, out of all these keywords, I just want to talk about bicycles or bike and exclude electric. Okay, let's say that I'm having some campaign, and then basically I get only 1,800 results, 18,000 results, and that's not something that is possible to do on a key value store in the memory. Like, it's too much. It's an abuse, but on the other side, loading 1,023 billion rows, and we're talking only about a year and a half of the new data. It's not something that we load to MySQL. Or we can try it, let me know how it went. Okay, so I said engine a lot of times, let's understand the concept. I will show prices, just an example, it's not relevant to what we're paying or some catalog cost. We have S3 database, and then we have a query engine or cluster. The first query is, as I mentioned, loading directly to the local SSD, first of all, and then the second query is already being processed on the data range. Okay, I will show you an example in a moment. And this gives me the flexibility, gives me the ability to say, okay, I take one cluster, one engine to serve the UI queries, okay, my customers' queries. And then I take another one for my API, because the API has higher load, so I want a more expensive engine, and I don't want to touch my UI customers. But I will have a third engine that I only need 1 hour a day. It will be probably very powerful, only to ingest new data. Okay, this is actually how we work, and that's something that is very hard to achieve without this mechanism of compute and storage separation. Okay, so I set data ranges, and I will try to explain what it means. So imagine that we have all the data about Amazon.com, all the data about Walmart.com in our S3 lovely buckets. And now I want to run a query. This is not how the query runs in production. Okay, it's very simple. I'll just make the point. I want to take all the URLs out of Amazon.com containing shoes. Okay? Let's say that I'm some shoes reseller. I want to explore this market. What happens is that now all the Amazon data, not only the shoes, has been loaded. Side note, depends on the index. We'll get that in a second. And then, okay. And then when I'm changing it to laptop, all Amazon data is already in the SSD. So the second query and the 100 query will be super fast because it's already in our cache. Okay, so this is the concept of data ranges. Of course, it depends on indexing. And now I will explain a bit about indexing. And if I remember correctly, then you will have some time for questions. Okay, so simple example. We don't have tables like that, but just for the concept. Let's say that I have a table with product ID, product name, brand, category, and price. Okay. Now, yeah. Okay. In general, the index should represent the most popular filters in the query. So, for instance, if my typical query will be like brand analysis, give me all the rows for Apple. So I would like the brand to be the primary index. If it's the category, so the category, and it can be also like string. Okay, so even though I'm looking only like partial part of the actual value, if the product will be the index, so this search will get optimized by the index. And we can also, and that's a native feature in Firewall, we can have aggregating index. So they have the primary, but they say, okay, now, deal database, I really need another mechanism, and I don't want to duplicate my tables, so it's doing it for me. It has some storage cost, but it's happening automatically, and that's giving me the ability to have multiple columns as kind of secondary index. It's not exactly like that, but that's possible as well. Okay, and sometimes life are more complex than that, and that's a real example, okay, from our Firewall system. So as you can see, we are putting the year, months, is organic, that country, main domain, device. All of them are part of the index. We are actually even sorting the data by the index filters, so we found out it's making a better distribution of files than mine. Number of rows, okay, promised 1 trillion, not billion, trillion, 23 billion, and that's 72 compressed terabytes, which are something like 300 terabytes in production. It's only one table. Okay, so as you can see, this is like the typical query. We have our platform is containing tons of widgets and tables and graphs that we are calculating. And this is an example where we are looking in the keyword, in the country, that's changed to main domain, device is organic and year month. Okay, and because this is typical, the typical query, this is why we choose to actually create the index by that. And this is actually important, but it looks like it's not what it is. What happens is that eventually this query runs in 7 milliseconds on 1 trillion rows. And the reason is that because we optimize the index, and it took a while, we got into a way that it scans only 15 megabytes out of 72 terabytes, okay? So get back to the ranges by the index. So we got into a situation that in order to find iPhone by the index, we only need to read a small chunk of 15 megabytes. Okay, and that's how important it is. And by the way, it's not only in Firewall, the general concept, but we are working with them. Why optimizing indexes is so important on distributed databases, because that's a concept that Firewall didn't invent. They are using many mechanisms, so it's really highly super important. Other than that, it can run for tens of seconds. Okay, last 4 slides about the actual production. So gratefully, we are monitoring. We're using Datadog for most of our monitoring system metrics, to be honest. So DynamoDB. So as you can see, DynamoDB again is like units per second. Think about it can handle a lot of concurrency. And what happens? Remember this peak here between the 10 and the 11. Okay, the latency, which is between 25 to 45 milliseconds, is not really changing. Okay, so we had peak here. It's not really affecting the database. It can eat all of it. That's real production, real customers, real requests. And in Firewall, we see, so remember we have 2 peaks on the 7 and on the 10, okay? Over when we get even to hundreds of requests, and then you see exact correlation when we're talking about latency, okay? So you really need to monitor your latency when we're talking about these databases, huge columnar like Firewall. And friends, thank you guys. If anyone wants to write me an email, you're welcome. Or you can talk to me after.
I think we should have also other microphones, but I don't know where, somewhere over here. So there seems there's no questions on Slido, but if there's someone from the audience who would like to ask a question, now is the right time to raise your hand. So, questions?
I have.
Perfect.
Oh, okay, hi. It works, okay. So about the indexes, okay, so I guess you have some downsides to indexing too much, but there's, I guess, oh, maybe I'm wrong.
I have what?
I guess there must be a downside to indexing too much, or not, but can it affect performance if you index too many fields?
So it's not about too much, but again, if it's wrong and if it's not matching your typical query, what will happen is that the mapping the database is doing between the index and the actual file, actual results, will be wrong, and then you will pay with performance. That's general idea.
Okay, but you might have situations like you said general query, but you might have more than you show that several cases of indexing. So what would you do? Just index all possible scenarios?
So the idea is that when I'm talking about main filtering, and maybe it wasn't clear, so in similar way, for instance, we will start from the domain. So I want to optimize that. Once I have the domain, the rest of the results, it's a tiny chunk from the entire data. And then the index doesn't really matter, because all of us can create a table with the 10,000 results, and that will be filtered easily without any indexing, right? So that's the idea. You're taking like the typical query that will give you the small word that you want to filter later on or manipulate, and this is what you're optimizing the index for.
Thanks.
You're welcome.
Some more questions? Yeah, over there.
I
Yeah.
think I have a question.
We hear you pretty well.
Yeah.
Turn it on.
It's
Just
Sorry.
check. Well,
Czech Republic.
yeah. You were mentioned that you have a special friendship with Amazon, and also you have a special deal with Firewall. Is it possible to use approach that you use in similar web in a different company, or I need to have friends with Amazon?
So wait, you can do everything that is shown here. We have special price with Firewall, but we are really like tight friend. Amazon are not so nice for us, okay? The only thing that they did is that they listened, and after 2 years, they created a trivial feature that actually saves tons of money. So they didn't have any intention, but they understood that it's really need to happen. But so of course, when you pay a lot, you get better price. But all the capabilities are available for anyone.
Thank you.
Just one more question.
Yeah. One more thing.
Yeah, one more thing. Okay, so as we understood, like Fireball is really so great solution for the data, but maybe you could just open some dark side of Fireball.
So many.
Yeah, and it's much interesting for us.
So first of all, to be honest, it's just got general available, okay? So I'm crazy enough to take it to production because we really had some dark edge cases, and believe me, we tried BigQuery and we tried Snowflake, and we tried Elastic was a mistake from the beginning. We tried really everything, and eventually they came up with something that is not stable but works, and we took it. Okay, it's paid off. Other than that, not related to bugs or stability, the product is not yet as mature as you will find maybe in Snowflake, some integrations, some features. And of course, that's not an important part. If you have intense read, write, delete, root, okay, operations, that's not database for you. Okay? It's not for managing, I don't know, list of users, waste of time, waste of thinking and money. Okay, so it's not for that. But for huge analytics, I really think that's the right place.
Any more questions? It's a good one.
Okay. So I remember reading Ahrefs, your competitor moving off cloud like a year ago or something. Have you considered that as well?
Move to what?
Ahrefs, moving off the cloud.
Off the cloud.
Yeah.
So first of all, I think they did it. They had, I think, some idea to create a search engine or something, some mechanism. We used to have our own servers. It ended up with a dramatic disaster. I think currently we don't have thoughts about that. It's probably paying off in some cases, but I think that the world where you're actually installing software on your hardware, I don't like it. Maybe if you're a bank, you have a lot of restrictions where the data is stored and how it goes physically from one point to another. Currently, and also big cloud operations today like Google and Amazon gives you all of the abilities to define when you want to store your data. So not currently, it's not allowed.
So you mentioned you have 50 megabytes index for 1 trillion of rows, is that correct?
No, I showed that the index is so efficient that it's giving you the ability to scan when you look for iPhone only 15 megabytes out of 72 terabytes. Okay. So imagine that the 72 terabytes are spread in a billion files. Okay? And then if your index is crap, so you will scan all those files, that will take forever, and you will actually scan 72 terabytes. That's the worst thing you can do. When the index is very efficient, so the ability of the index to say, hey, iPhone is here, okay? And what happened behind the scenes? It scans only 15 megabytes. So that's cool. Yes.
Quick one. Do you track how big is your index, and have you ever had a problem about the size of the index itself?
Yes. I mean, what I'm showing you now is a project of, I don't know, like 6 months of operations. It's really not trivial. Talking about Ahrefs, they invested like 2 years, I think, of like it's a thing. I think the most problematic thing, specifically by the way in Fireball, is that eventually what happened behind the scenes is that indexes and secondary indexes are like creating hidden tables. The good news is that it's saving you the work from managing multiple tables. So this is by keyword, this by size, but many indexes like that eventually also they need to be loaded, right? Remember the SSD, and then you are exploding your cache with the index itself. So yeah, that's like very. This world is very sorry. That's the experience we had. So yeah. Okay. So no other breakable. So good luck.
No more questions? Okay. That takes us off. Is it? It's supposed to be off, but maybe it isn't. All right, so I would like to thanks again for the presentation. And our next speaker is Daniel from Dativery. So the floor is yours.
So, hey everyone. So, my name is Dan, and today I want to tell you something about using AI in the software development lifecycle. So, as was said, I work in Backendisti, which is a company and we integrate applications together. Though this is not too much of a topic of today's presentation, because the presentation I actually did for my diploma thesis. So yeah, that was for my alma mater, Technical University of Wales. So yeah, let's start with this. Essentially, everyone these days is saying that AI is going to take our jobs. So I'm here to say that it's not that easy and tell you why. The goals for this project was to test the use of AI as a co-pilot in the areas of analysis, software design, of course, coding and testing and refactoring and CI/CD. As for the project itself, here you can see an image. It's a simple web app. Nothing special. As for the functionality, it shows weather, it shows like maybe some rain information, humidity, and some air quality. It's a single page app, and I actually chose like probably not the best tech stack you can choose, but the goal of my tech stack was to cover as many things as possible. So that means I actually have a backend in Python, which probably wouldn't be necessary anyway. I have a front end in React. The weather I get from various APIs, and there's a database. There's some authentication baked here, which just routes to a test Stripe instance, so nothing special. And I deployed on the cloud. I chose Firebase for the front end hosting, and Heroku for the backend hosting, and CI/CD, which is essentially just GitHub Actions, because I'm not a DevOps expert, honestly. Yeah, so here, if anyone wants to pull up your phone and scan the QR code, you're welcome. Here's the QR code for the application. It goes Git, up. And here's the QR code for the deployed application on Firebase, the URL. If you want to try it out, so we may not see every feature because it's baked here. Yeah, here's a repo for the prompts. If anyone is really interested, here you can see essentially all the conversations that I had with AI regarding the code base and the creation of this project. Yeah, sorry. Can I continue, or anyone else wants to scan QR codes? So I don't block anyone. Anyway, the models used were for analysis and design. I used ChatGPT. It's kind of important to say firstly that it was done in like 2023, so essentially all the models are now obsolete. Thanks. And yeah, so I used ChatGPT on the GPT 3.5 model. I used Bing Copilot, which is allegedly GPT-4, but I never believed it because the performance wasn't that great. I used Claude Instant, which is the first, essentially the first version of the Claude model. Also some outputs. These two are open source models. And yeah, and as for the other ones, GitHub Copilot, which you might be familiar with, and Bard, which is essentially now called Gemini, but then it was just called Bard, and also I had a different model. Because after analysis and design, I found out that I have like a real lot of information, then I just narrowed it to Copilot, because it was mostly because the answers were very similar in analysis and design, so I just said, hey, I don't want to go through all of that, so I'm just going to keep with Copilot. Also, it helped that it has a really good integration with VS Code. So, this is the transformer, and it's the basis of all the various large language models used these days. I'm going to try to explain it really simply. If anyone has any other questions, feel welcome to ask later or even after the presentation. So, what a transformer does is does next word prediction based on the previous context. As for the process itself, first it tokenizes the input, which essentially means that it takes words and converts them into numbers. Then it does embeddings, which means it takes these numbers and converts them into semantic vectors, essentially vectors that capture the meaning of the word, just the word. Then there is attention. Attention, what it does is that it transforms this vector to enhance the meaning. For example, if you have a sentence, apple is a fruit, and I bought an Apple product, there are distinctly different meanings of the word apple. And what attention does is that it takes this like generic semantic vector for apple and modifies the numbers inside it to more match either a fruit or a technological company. And then there is a linear layer and a softmax layer, which essentially just like predicts the next word. And then you repeat based on the whole previous context. On the whole, you only take the context window, which is the number of words that you take into consideration before you actually predict the next word. I think ChatGPT has like 3,000 spoken, so maybe like, I don't know, maybe 2,000 words of context window. Then there is RAG, and yeah, that's a more advanced thing, but what it essentially does is that it does grounding. It provides real context and therefore constrains the answer of the model. What it means is that, for example, if you ask what are the free-tier cloud services today, because nobody wants to pay money for hobby projects, you get an answer with RAG, you get an actual answer that matches today. With just a model, you would probably, because of the training data, get an answer that matches like 3 years ago. And since I do a project today, I kind of want to just have an answer today. So what things use this? For example, Perplexity, which is an AI search engine that probably what it does under the hood is exactly this. That it takes like web search results and does retrieval augmented generation or RAG overdoing to get the most up-to-date information. So it improves response and reduces hallucinations. Here's schema. Essentially, you take the documents, you embed them, which I said, embedding into vectors of meaning. Then you have a vector store. You also take a query from the user, which then you also embed, and you do some similarity metrics to get the most relevant documents for this query based on like similarity of vectors. that goes into an LM and that goes into an L. And therefore you get a more true response. So let's go to the project itself. First step is analysis. Analysis, I did some some questions for customers, which I was pleasantly surprised by how the model also tells me other things that a programmer might not think about. And if I'm a single developer working on an app, this could be very handy because, I don't know, I don't think about branding, I don't think about user experience, I don't think about monetizing, mostly think about code, and I want to deal with this stuff later. So yeah, it's maybe a good use case. Then some clarifications. This is important because most models, when I asked for clarifications, and I did not ask in a good way, I just essentially copy-pasted like some list of requirements and said, I have gotten these from my customer. So the model obviously doesn't know what I want, so it just does whatever it wants. But it's not the best way to prompt LLMs. If you want to prompt, you gotta know exactly what you want, or you can iterate. As for the models, for example, the model Falcon just gave me like recommendations of APIs, and the model Qual actually gave me other questions, which I wanted, but I didn't specify. So yeah, my mistake. Architecture, it's kind of nice that I got recommended serverless architecture because I did actually want to minimize operational costs, and at the time I didn't really think about using serverless for the app, but yeah, it's the best decision if you do want to minimize costs. If the app is not going to have that much traffic, and since it's more of a hobby project, it's probably not going to have that. There's some risk management. I was pleasantly surprised by like the recommendations of like burnout, which honestly, if you're a solo developer, it kind of makes sense. But yeah, it's kind of fun. And as for additional features, I just asked if it could give me some other features, maybe customer support isn't really that much of a feature. Analytics, yeah, I probably would have forgot that. Subscription management, kind of Stripe kind of takes care of that. And discounts and promotions, yeah, that's also another one. So as for the text, as I said, you gotta know exactly what you want. Like if you're gonna just write into the LLM, hey, I got this, and you're not gonna specify what you want, and you're not going to be explicit about it, don't be answered when you get an A answer. If you don't know what you want, you can ask a lot of questions. You can try to clarify the stuff with the model, and then construct, like iteratively get to the best prompt, and then put that prompt in. And you can also use AI with sources, as I said, Perplexity, which also is pretty good because it gives you more up-to-date information. If you're, for example, I don't know, thinking about using an API, you probably don't want to get like a year-old documentation response because. So design, tech stack recommendation. Do not read the prompt, but what I wanted to say is that the prompts can get really lengthy if you specify exactly what you want. So the most important thing is what tech stack, recommendations and alternatives, lists of other libraries that I can use. And here, for example, Copilot just said no, and gave me just like a list of technologies without any alternatives, without any like other libraries that I specified in the prompt earlier. So it's not the best response. It was the only one this way, but what's great is that I can just ask further because one thing that I think is better for AI for tech stack recommendation is that you can just iteratively ask back and forth, back and forth, back and forth. Give me alternatives. Why is this better than this? Why is this better than this? And if you use a search engine, you're going to get there, but you're going to probably get there a lot slower. And since AIs these days are maybe just like Google on steroids, that kind of makes sense to use it. Yeah, so hallucinations, because they gotta be here. Should I use functional or object-oriented design for my application? I got a hallucination that first I'm new to web development, which I didn't specify anywhere. And also that functional designs are simpler, which I guess I'm not so sure about, since functional programming is definitely not simple. Also, second batch of hallucinations, I asked for the other libraries. I got NumPy, Matplotlib, even though I'm visualizing data on the front end, so like, why? And yeah, Heroku is for free these days, except it isn't for like 3 years or something. Though I gotta admit, use of design patterns kind of helped here because I'm not that strong in object-oriented programming. So recommendations of which parts of the app would fit which pattern are kind of nice. For simplicity, I just asked, hey, should I use REST or GraphQL or something else? It told me that GraphQL is overkill, which I totally agree with. And UML, I tried to prompt a text model for an image. How should that go? Actually, it went well with one model, but the 6 other ones either gave me a nonsense text file or just nothing. Here I have a response from Vault, which I got in a text format, but I could compile it in the browser to actually show something like the UML chart. I agree with the classes, but the connections are missing. So yeah, tips. Maybe you can use too much context, because I think when I did the very long prompt for the recommendations, tech recommendations, I got somewhat like not good response just because I did too long of a prompt. It's still better than search engine, I already said that, and I wouldn't rely on chat history too much, because what also happened is that I essentially, let's just imagine a scenario. I asked in the beginning of the chat if it could recommend me some technologies. And then I asked it very, very, very late in the chat if it could give me a folder structure. And the folder structure was nothing like the technology that I asked for earlier. For example, I got React as the recommendation, and the folder structure was more like a Django Python project or something. So yeah, if you need a specific context thing and you know that you are outside of the context window, you might want to reconsider if you do not put it back into the prompt itself, like to refresh the model essentially. Yeah, so implementation, I did code generation, who would have thought. I also tried refactoring with like some various keywords. And yeah, I tried testing and documentation. For the libraries, sometimes I got a good response, for example, with request cache, but sometimes I got a bad response, which is this fast API CSR protect library, which exists, but this method doesn't exist. This method does, but the whole like CSR protect middleware never existed. It's actually probably a method from another library. So yeah, if you want to use it for a library that is well known, go ahead. If you want to use it for a library that you know is probably not going to be that well known, which essentially a CSR protect library for fast API framework, probably not it. So don't use it. Just use the documentation. I actually got some interesting recommendations for basic languages or well-known libraries. Here, you could send, for example, for the data class, the slots parameter, which improves performance. Or here, I got for example, functional methods in JavaScript, which are also non-trivial. So I would like to say that, yeah, in cases of like the original language or libraries that are well-known, sure. But if it's not a well-known library, then yeah, I would be kind of skeptical about it. Yeah, and repetition, because if you try to debug something with AI, it usually just ends up repeating itself, which happened over and over and over and over again. So here's an example. I simply asked, hey, I got this error, and it gave me the code. I then asked, I got error on this code, and it gave me the same code, just a different text. So yeah, they're the same picture. I'm like, I don't know, like, could you help me debug this stuff or no? Yeah, simple refactoring. I just asked, give me refactoring tips. I got tips, which like, yeah, fair enough. But it wasn't enough for me. I kind of wanted to use it more complex. So that's another big problem. which is a prompt chain that I ask like, this is the first question, I got a response. This is the second question, I got a response. Third question, response. Fourth question, response, etc., etc., etc. And here I got some interesting tips like other libraries for parsing JSON for performance or performance on the front end using some list virtualization, or essentially some React memo and use callback functions for optimizing my front-end React code. So yeah, the performance aspect was nice. Also some readability, for example, I have abstract called dependency injection was actually kind of new for me, so I did appreciate it. This is probably not relevant. And yeah, it also did like analyze my test names, which I really would care about test names. And yeah, I also asked about performance because I'm a performance junkie, and it told me that yeah, the performance of your like tests probably isn't a concern, and you shouldn't care about it much. Yeah. So tips for implementation, refactoring, blah blah blah. Use for complex refactoring, boilerplate, simple test generation, and exact functions that do not contain domain knowledge. Because, and here we go back into that today. Where I work, we actually work with like accounting stuff. And yeah, here I would not exactly use like ChatGPT for helping me to understand accounting because like it's probably not on the top of the training data, and it usually didn't pan out too well when I try to like understand it on my own. And yeah, for example, libraries use AI sources, or maybe if the documentation of the library is small enough, just copy paste it into the context window of the model. Because these days you can context a very long, you can paste into the prompt a very large amount of text and it will still be able to comprehend it. I'm not sure where the limits are, but last I heard it was like 100K tokens, 200K tokens. So yeah, it's very long. You can probably paste a decent amount of documentation in there. And yeah, use prompt chains for best result, or essentially just yeah, be exact in what you want. As for CI/CD, I did some test reports, some document generation, and I used GitHub Actions. What I didn't like was that I got old versions of scripts, which yeah, like you can just search on Google if it is the newest version. But then again, if someone doesn't, then you're just like exposing yourself to security vulnerabilities for nothing. So for tips, here in this stage, I would probably rather use just the documentation. And the point being that AI is usually good with like doing specific things and making functions, etc. But what I found is throughout the project that it's probably not that good in connecting pieces together. That the connecting still has to be done by the human. But yeah, you can use AI for the generation of the code, etc. So as for the summary, thoughtful analysis, what I think by that, what I meant by that, by these keywords, is that you're talking with a customer, you can have ChatGPT on your phone, and it can save you money and save the customers money because, for example, 3 questions you wouldn't know about, and therefore you would have to ask them again. And because you use ChatGPT, now you know, and you can save money because you don't have to ask these 3 questions again and modify the implementation, etc., etc., etc. As for the design, something called verify design. Verify, what I mean is that essentially it's just a big search engine. So yeah, if you want to verify your design and verify what are the alternatives, what could be the different ways to design this, etc., it might be good to use AI for that. As for the implementation, what I mean by abstracted implementation is that I found that I didn't really have to write a lot of the code myself, but I still had to, like, as I said, connect the pieces together, think about the problem, understand the code, at least a bit, the high level overview. But yeah, like the low levels, well, not low level, but more like the boilerplate and stuff, you can just let it write the React component for you and just kind of tune it a bit to let it do what you want to do. So yeah, and effective CI/CD, just that I didn't have to write DevOps scripts because yeah, not my best pastime activity. yeah, so last thing I wanted to talk about was the differences in the levels of software development lifecycle, because that was actually a question that I got asked when I was doing this for my thesis. And I think the biggest differences are, of course, the training data, because the model has seen Python functions over and over and over and over again, but maybe it hasn't seen so much like software designs. Also, the context of the application, because the model doesn't have like the context of the application itself. If you just use the plain vanilla ChatGPT application on the web. Developer experience, which I think is still important, and that's one of the reasons why I said they are not going to take our jobs, because like you still have to know exactly what you want, as I said. Like if the better you know what you want, the better response you're going to get. Therefore, still having experience with development, then you can ask better questions, therefore get better answers, therefore just be better. And yeah, like it's not that it's this silver bullet that, yeah, I read 10 books on software architecture, ChatGPT is gonna write everything for me and I'm gonna, I don't know, be a super duper developer. Doesn't work like that. And the solution space, which is one thing that I kind of interested about. What I mean by that is if you do analysis, there are like tons of ways to do the tech stack, do the analysis of the application. But if you're testing one function, there's like few ways to test one function. There isn't that many ways to like test the function. So then it kind of makes sense that in testing, I maybe got better performance than in the software analysis, because the number of options was very small, so the model takes some of them and yeah, went on. But when there's the number of options is very big, and you also don't get an ideal response from the user, as I mentioned earlier, then you get an if response. And training data, it's, yeah, you get outdated responses and stuff. But since the models are updating quite frequently, I think this is changing for the better. And this on a more practical note, I wanted to talk about the toolbox that you can use. I just put chatbot as novice because, like, well, basic prompt identifier, it's enough, but a lot of the things you can do in there. The basic, I did use Copilot in this. And what I liked about Copilot is, for example, that using agent, which is a feature that you call from the prompt window, you can essentially like scan your whole code base and get the responses based on the code base itself. So that means I can take my code base into account and say, hey, generate this function, but also check if it isn't present, if a similar function isn't already present in the code base. And then it can tell you, hey, this function is already in the code base, therefore you won't therefore you won't have duplicate code. But you also get the benefit of, just knowing this. And there's Cursor, which is more, let's say, automatic AI IDE, which is based on VS Code, and it has this interpreter mode, which essentially debugs stuff for you, and you just say yes, no, yes, no, yes, no. So yeah, so that's also an option. More advanced stuff, there's LangChain, which is used for prompt flows, which you can imagine that you go through multiple prompts before getting an answer. And then you have function calling, which essentially just means that you have a function, you give it some semantic meaning. So for example, this function fetches weather. And the model, if you prompt it, and it recognizes that you're talking about fetching the weather, it will actually use this Python function, execute it, instead of just, I don't know, trying to fetch the weather with like, it's like with an L language, doesn't it? And yeah, there's agentic workflows, which are very similar to prompt flows, but you essentially combine multiple AI. So that means you have an AI that is a senior product manager, you have an AI that is a senior developer, you have an AI that is, I don't know, project manager, whatever, and you essentially put a task, and they do the task, and they try to communicate together. It's kind of like a company, but yeah, it's quite complicated in a way that it has a big learning curve. And what I consider to be like expert level, or not really expert, someone might disagree, but for me, is, for example, instruction fine-tuning. So you fine-tune the model to do exactly what you want. LoRa, which is, that's just like an adapter in front of the LLM, and soft routing, etc. So I think, I'm just going to skip this because it's getting too lengthy. And so here I have an AI jumpstart. If anyone is interested, you can copy these links. I try to like at least give you the practical stuff in the way that this is the most important like links and resources that I found on my way to learn generative AI. I'm not saying they're the best, but it's what I found. And also a lot of videos and stuff that they mentioned, but as I can say, rest you can find if you are curious enough. And yeah, so now I guess for questions, I'm going to leave this here for anyone to.
So thank you for the presentation. And one more time, if there are questions in the audience, please raise your hand. And I'll try to pass the microphone. Okay, here we go.
Thank you for presentation. I have maybe more than one question. First of all, what version of ChatGPT was there?
So I actually used for ChatGPT itself. I got GPT 3.5 Turbo, I guess. And as for Copilot, it was GPT 3.5 Turbo for some amount of time, and then they like mid-project switched to GPT-4. So then I got GPT-4, and I can say that the difference was really big. Like,
yeah, and so we can say that the whole presentation is like a little bit outdated.
Yeah, it's updated in the fact that it's maybe not as relevant, but I tried to capture the like, let's say, big picture things, and not like the extreme details.
Yeah, and I was thinking that using AI for software development, it's like using Airbus like a family car, because nobody, and maybe I'm speaking for myself only, nobody really cares about how ChatGPT will write your code, because ChatGPT can make your code useless because you don't need to program anything. For example, you made a weather application. Why should I use this application right now if I can ask ChatGPT to like display my weather in a better way? Why should we build software not for getting solution, but like use AI, just receive the solution exact from AI?
I mean, I more built the app to test the depths of like what I can get into. I don't know if that was like explicit from the presentation or not, but the app was in itself more of a like experiment. It was just like a tool for me to test, but it didn't like really go after some goal, like use the application or so. It was for me to test as much as possible on the AI.
Okay, thank you.
So some more questions. All right.
Did you try to use some prompt tricks, for example, suggesting to paint some tips for good answer?
I mean, I didn't try these, and I also didn't want to go too in-depth with these because I wanted it to be like the average programming experience. So that means like the average programmer is just going to sit down, write a prompt, and give me an answer. And I don't think they're going to want to like 15 minutes just reiterate on the prompt. Though I said you should, but most people are not going to do it. So therefore, it was for me, it was more important to just like kind of be lazy because everyone else is going to be lazy. So like target audience. I don't know.
Thank you.
Hello, one more question. What you can say for students who want to be developers? Do you want to say that you don't need to worry about AI? AI will not replace you?
I mean, first, you still have to learn how to use it. I still believe that, but I also believe that you still got to know the fundamentals. Because if you, I don't know, for me, programming is problem solving. And problem solving, like people who problem solve on punch cards, have a similar brain to the people who problem solve now. So we will still need problem solvers. And also, if you want to build an application, like you gotta have some experience under your belt, and you gotta know like how the basics work to be able to build something from. So I still think it's worth coding, it's worth exploring. Just that it's also not good to just say this doesn't exist, I'm not going to care about it, let's go on. Because yeah, it's here, and you gotta learn it. And as for the students, I just don't think programmers will be replaced, honestly. Like my take is that still problem solvers will be here. You might have to change the way you program, might happen. It's changed in the past, as I said, punch cards, Python, but that doesn't mean we don't need problem solvers right now. Like we will still need problem solvers in my opinion. And AI for domain stuff, like, not great. Like domain problem solvers. Might be that programmers will actually need more domain, but yeah, this is my thing.
Yeah, actually agree with the answer. So any more questions? So I will bring the microphone.
Yeah, hello, thank you for the presentation. I have two. Can you quantify more or less how much time did AI save?
That's a hard question, but I didn't measure it and didn't really track it, but I mean, yeah, I mean, I think it saved at least 50%.
50%.
At least 50%.
Cool, thanks. The second, I have the feeling when I ask ChatGPT to do code for me, that then I kind of forgot what ChatGPT did because I didn't put effort on it. Have you ever faced a problem in which like you did something thanks to the AI, and then you have to go back and you're like, what the fuck is here?
Yeah.
You don't need ChatGPT for that.
It's like, yeah, it's bad. Like you kind of like want to use it, but then you should also understand it. And it's like people are lazy, they don't understand it, and they come back and they're like, yeah, what the fuck. So it's, I don't know, I guess I don't really have a concrete answer for that because I encounter this myself. Like, yeah, use ChatGPT or something, then you go back, and you have to refactor it. It's like, yeah, I don't know this code. So yeah, I don't know. Maybe it would be better if you actually get like the code also like automatically ask for an explanation. Like just like integrating it into your head, code explanation, and then you at least might be able to like remember what happened instead of just copy paste paper. Let's go on. So yeah, that's probably my take on it. But I know that people are lazy, so it is what it is.
I have a question as well. Have you ever tried using ChatGPT for understanding a code that you wrote some time ago?
I mean, I did try to use ChatGPT for understanding, or Copilot more for understanding a code that I didn't write, and it was good, but like, since it doesn't have the whole context of the code base, even with what I said about Copilot, that it can read the word like the whole code base, but even still, it used like very very specific variable names that like you have to know them. It just used the variable names in the code. Therefore, you have to know what's behind the variable name anyway. So it helps, but it's also like you gotta like it eases the process, but you still have to find stuff on your own. Well, it can help you search that stuff. Well, yeah, it isn't a silver bullet. It's not going to explain code like crazy.
Maybe in the future. I had some other questions. Cool.
Yeah, I have seen some large prompts in the presentation you used, and I wanted to ask if you observe some correlation between prompt size and the quality of the output.
Like what I think, and it's not exactly, I will not exactly call it observe, but think, is that there is like a sweet spot, and if you go too much, the model will just essentially start to lose track of what you said in the beginning, or just get mangled in, like, it will start skipping details, etc. And there's also too little. Like if it's not a simple thing and you just ask one question, then the model will just like, yeah, so what do I do? It will just like pull out a random thing and hey, here you go. So yeah, I think there's a sweet spot. I'm not sure where the sweet spot is, but there's definitely a sweet spot.
Okay, thanks.
Any more?
Hi, have you tried, so if it's like a bit outdated, have you tried like more recent models, and have you tried like, for example, GPT-4.0? Like, and
I didn't really try GPT-4.0, but Copilot right now has GPT-4 Turbo, which isn't that far up, and in terms of performance, and yeah, it's pretty good at what it does, and I'm kind of lazy to use GPT-4.0 because of the integration that Copilot has with the IDE. Because there's like real tight integration, but if I do something in GPT-4.0, it's more like, yeah, I have to paste this piece of code and I don't get like at least some context of the code base and stuff. But yeah, for me, there's improvement, but I still think it is in a silver bullet. It might be in the future, but.
No, I was more interested in you, like, doing some sketches and then putting them in GPT-4.0 and generating some code from them or something like that. Because it's like, omni-channel, so it can get like...
Yeah, the multimodality I didn't use. I had like an idea that I would essentially sketch a UI and put it in there, get a React code, but yeah, I didn't try it. But it's in the plan to do a Figma design and just put it in there and see what happens.
Once your company starts paying for it, right?
I mean, 4.0 actually has some free prompts, so I guess that's enough for my experimentation.
Thank you.
Someone else? No? Okay, in that case, thanks for the presentation. And thanks for coming. But don't go home yet, because now is the time for networking, which is probably the most interesting part of the presentation, or the talks. I don't know, I'm just kidding. So the speakers will be here, so you'll have the opportunity to talk with them as well and ask them some extra off-the-record questions or whatever you like. And there's still some food left, so have some refreshment, have some beer, have some, I don't know, non-alcoholic drinks, whatever you want. And thanks again for coming, and I hope to see you next time.